Okay, let's have a look at how we go about reversing the chain rule. Let's revisit what the chain rule really is. Check that you remember it. We know that if y equals ax plus b, all in brackets, to the power of n, how do we differentiate that? Well, we can do it the slow way, saying dy dx is equal to dy du times du dx, but we can also do a quicker way that we learned, which is to say we've got to bring the n at the front of the brackets. We've also got to differentiate what's in the brackets, which will give us a, and bring that out the front as well. So we get our a out there, we also get our n out there, and then we have to rewrite everything that's in the brackets and drop our index number down by 1. And that's what we get. So let's think now what we're going to need to do if we're given the derivative and we need to find the primitive function, or y. Now, there's nothing out the front of this, and there's also nothing down the bottom. So we're going to have to think about how to get it looking all nice and tidy like this. Now, what we just learnt before was that if we have just a very simple term, then we know that we need to add 1 to the index, and we need to divide by the new index. So that's a good start. Let's start with that. We'll put our whole ax plus b in brackets, and instead of to the power of n, let's up that and say we want n plus 1. Now we can use a process of elimination here to work out what will happen if we differentiate this. Will we get that? Because if not, we can adjust this until it does look good. If we differentiate this, the n plus 1 will come down the front. Well, that's no good because this one doesn't have an n plus 1 down the front, does it? Well, we got over that last time by putting the n plus 1 down the bottom. So let's do that again. That seems like a good idea. All right, but when we differentiate this, now the n plus 1 will come down the front and cancel with this. So they'll disappear. That's good. The n plus 1 will drop down to being just n. Sweet. But we can have another problem. When we differentiate this, we need to bring the a out the front because we've already acknowledged that that's part of the rule. And we don't want an a out the front. So what do we need to do? We need to put an a down the bottom so that when the a comes out the front, it'll automatically cancel with the one that we've put here. And that's our rule. So we can go ahead and put a box around it. And let's also write it in words. So in words, what we need to do is increase the index by 1. And we need to divide by the new index and by this a. Now we could say that we're dividing by a by saying it's the coefficient of x, and by the coefficient of x. And there's something that we can't forget at the end. What is it? You're getting this by now. We need to add a constant. And add a constant. So what we had up here wasn't finished. Add a constant. Now, when we were just using a single term, we had 3 things to remember. Increase the index by 1. Divide by the new index. Add a constant. Now we've got 4 things in this little reversing of the chain rule. Increase the index by 1. Divide by the new index. And divide by the coefficient of x. And add the constant. So, one more step to remember there. Okay, this question doesn't have any y's or f of x's or dy dx's in it. It just says find the primitive of some term. No problem, we don't need those y's and other things there. We can take this whole thing and apply our rule to it. So we've got 4 things to remember. First thing is increase the index by 1. So we need to rewrite everything that's in the brackets and increase the index by 1. We need to divide by the new index, and we need to divide by the coefficient of x. So the new index is 5, and the coefficient of x is 3. So we're dividing by 3 5s, which is 15. And one last thing to do, add a constant. And that's our answer.